Chapter 12. How the Internet Finds You. Nimbus was running. The load balancer had a public IP. The EC2 instances had a private IP. The databases were locked in private subnets. Priya had nodded approvingly at the network diagram. Tom looked at the load balancer URL, nimbus-alb 123456789.useast1.elb.amazon.com. That's what customers type into their browser? He asked. That's what AWS assigns automatically, Maya said. I'm not putting that on a business card. Neither am I. They needed a domain name. They bought eatnimbus.com from a domain registrar. Now they needed to connect that name to their AWS infrastructure. How does the internet know that eatnimbus.com means the load balancer in US East 1? Leo asked. Good question, Leo. The phone book analogy. Before smartphones, every city had a phone book. If you wanted to reach Mario's Pizza, you didn't memorize their phone number. You looked up the name, got the number, and called. The internet has its own phone book. The Domain Name System, DNS. DNS translates human-readable names like eatnimbus.com into machine-readable IP addresses like 203.0.113.42. Every time you visit a website, your computer silently looks up the domain name in DNS and gets the IP address to connect to. If you changed your server's IP address, you'd update the DNS record, like changing your number in the phone book, and the internet would find you at your new location. Meet Route 53. Amazon Route 53 is AWS's managed DNS service. It's called Route 53 because port 53 is the standard DNS port. Sometimes AWS names things straightforwardly. Route 53 does several things. Domain registration. You can buy domain names through Route 53 directly. DNS hosting, hosted zones. You create a hosted zone for your domain, and Route 53 manages the DNS records that tell the world where to find you. Health checking. Route 53 can monitor your endpoints and route traffic away from unhealthy ones. Traffic routing policies. Route 53 supports multiple routing strategies beyond simple DNS. Weighted, latency-based, geolocation, failover. DNS records, the phone book entries. A DNS record maps a name to a destination. The most common types. A record maps a name to an IPv4 address. eatnimbus.com, 203.0.113.42. AAA record maps a name to an IPv6 address. CNAME record maps a name to another name, an alias. www.eatnimbus.com, eatnimbus.com. MX record specifies which servers handle email for the domain. TXT record stores arbitrary text, commonly used for domain verification, proving you own the domain, and email authentication, SPF, DKIM. For Nimbus, the primary setup. eatnimbus.com, a record pointing to the load balancer's IP. www.eatnimbus.com, CNAME pointing to eatnimbus.com. API.eatnimbus.com, a record pointing to the API load balancer. Wait, Tom said. The load balancer's IP can change. AWS said so in the documentation. Good catch, Tom. Alias records, AWS's solution to dynamic IPs. Load balancers, CloudFront distributions, and S3 websites have DNS names, not static IP addresses. The underlying IPs can change. If you create a CNAME pointing to a load balancer's DNS name, it works, but you can't use CNAMEs for root domains, eatnimbus.com without the www, because of DNS standards. Route 53 solves this with alias records, an AWS-specific extension to DNS. An alias record maps a name directly to an AWS resource, load balancer, CloudFront distribution, S3 website, and Route 53 handles the dynamic IP resolution automatically. Alias records can be used at the root domain level, and unlike regular DNS queries to external services, alias record queries to AWS resources are free. So we use an alias record for eatnimbus.com pointing to the load balancer, Leo confirmed, and Route 53 handles whatever IP the load balancer is using at any given moment, Priya added. For free, Tom said, suddenly very interested. Routing policies, more than just where is it. This is where Route 53 gets interesting. DNS isn't just a lookup service. It can be a traffic management tool. Simple routing, one record, one destination. Standard DNS. Weighted routing. Split traffic between multiple destinations by weight. Send 90% to the new server, 10% to the old server during a migration. Adjust the weights until you're confident in the new server. Then switch to 100%. Latency-based routing. Route users to the AWS region with the lowest latency for them. A user in Seattle gets routed to US West 2. A user in Tokyo gets routed to AP Northeast 1. Same domain name, different destinations. Geolocation routing. Route based on the user's geographic location. All European users go to EU West 1. All North American users go to US East 1. Useful for data sovereignty, keeping EU user data in EU regions, or content customization, language, currency, failover routing. Designate a primary and a secondary endpoint. If the primary fails Route 53's health check, traffic is automatically redirected to the secondary. This is the DNS layer of disaster recovery. Multi-value answer routing. Return up to 8 healthy IP addresses for a query, letting the client choose. A simple alternative to a load balancer for distributing traffic across multiple servers. So Route 53 is not just a phone book, Maya said. It's a smartphone book that can route calls based on where you're calling from, and disconnect you if the number is unhealthy, Priya added. Health checks. Routing around failure. Route 53 can monitor your endpoints with health checks. If an endpoint fails, Route 53 can remove it from DNS responses, stop sending traffic there, trigger a failover to a backup endpoint, send an alert via CloudWatch. Health checks are the link between DNS routing and actual application health. In a failover configuration, Route 53 monitors the primary endpoint every 30 seconds. If 3 consecutive checks fail, Route 53 starts returning the secondary endpoint's address. This is not instantaneous. DNS has propagation time. Once Route 53 changes a DNS record, DNS resolvers around the world need to pick up the change, which can take seconds to minutes, depending on TTL settings. TTL, the DNS cache. DNS responses are cached at multiple levels, at your router, at your ISP, in your browser. The TTL, time to live on a DNS record, tells caches how long to remember the answer before checking again. High TTL, 1 hour or more. Fewer DNS queries, less load on Route 53, but changes take longer to propagate. Low TTL, 60 seconds or less. Changes propagate quickly, but more DNS queries are needed. Before a planned migration, updating DNS to point to a new server, lower your TTL to 60 seconds a day in advance. Then when you make the change, it propagates in about a minute. After the migration, raise it back to the normal value. If we just lower it during the migration and not before, Leo said slowly, the old TTL means some users will see the old server for an hour. Exactly, Priya said. DNS migrations require planning before the migration, not just during. Strengths and limitations. Route 53 is the right choice for registering and managing domain names entirely within AWS, routing traffic based on latency, geolocation, or weighted distribution across multiple endpoints, health check-based failover between regions or between a primary and a disaster recovery endpoint, integrating DNS with other AWS services through alias records. When Route 53 is not what you need, Route 53 is a DNS service, not a load balancer. If you need to distribute traffic between multiple servers or containers within a region, use an application load balancer. Route 53 cannot do weighted round-robin at the connection level the way a load balancer can. Latency-based routing across regions adds cost and operational complexity that only makes sense when your users are genuinely distributed globally and milliseconds matter to conversion. For most single-region applications, a single A record pointing to an ALB is all the Route 53 configuration you need. Summary: DNS translates domain names into IP addresses, the Internet's phone book. Route 53 is AWS's managed DNS service, domain registration, DNS hosting, health checks, and routing policies. A records map names to IPv4 addresses. C names map names to other names. Alias records map names to AWS resources. Load balancers, CloudFront, S3. Use alias records, not C names for root domains and for resources with dynamic IPs. Routing policies go beyond simple DNS. Weighted, traffic splitting, latency-based performance, geolocation, data sovereignty, failover, disaster recovery. Health checks monitor endpoints and automatically remove unhealthy targets from DNS responses. Plan TTL changes before migrations. Lower TTL in advance so changes propagate quickly. Exam tips. SAACO3 domain, design high-performing architectures. Domain 3, task 3.4. Alias versus CNAME. Alias records can be used at the root domain. CNAMEs cannot. Alias records to AWS resources are free. CNAME DNS queries are priced. When the exam asks about mapping a root domain to a load balancer, alias record. Routing policy use cases. Common exam scenarios. Gradually migrate traffic to a new version. Weighted routing. Route users to the nearest AWS region. Latency-based routing. Keep EU user data in EU regions. Geolocation routing. Automatic DNS failover when primary goes down. Failover routing with health checks. Route 53 health checks can check HTTP, HTTPS, TCP endpoints, and can trigger CloudWatch alarms. Exam uses these in disaster recovery scenarios. TTL and propagation. Know that TTL controls how long DNS resolvers cache a record. Short TTL equals faster changes. Exam scenario. The team updated DNS but users are still hitting the old server. TTL too high. Private hosted zones. Route 53 can create DNS records that only resolve inside of VPC. Exam uses this for internal service discovery, e.g. database.internal resolving to a private RDS endpoint. Route 53 is global. It's not deployed in a region. No region selection is needed when creating hosted zones. Exercises. Exercise 1. Recall. Explain the difference between a CNAME record and an alias record. When would you use each? Hint, consider the constraints on CNAME at root domains and the behavior of alias records with dynamic AWS resources. Exercise 2. Exam practice scenario. A media company operates a website from two AWS regions, US East 1, primary, and EU West 1, secondary. The team wants traffic to automatically route to EU West 1 if the primary region becomes unavailable. The company also wants to verify that this failover mechanism works correctly without actually taking down the primary region. Which Route 53 configuration best meets these requirements? A. Weighted routing with 100% weight on US East 1 and 0% weight on EU West 1. B. Latency-based routing with health checks on both endpoints. C. Failover routing with a health check on the primary endpoint and a secondary record pointing to EU West 1. D. Geolocation routing with North America pointing to US East 1 and Europe pointing to EU West 1. Hint 1. The requirement is automatic failover when the primary goes down. Which routing policy is designed exactly for this? Hint 2. Test without taking down the primary region. Health checks can be manually set to unhealthy for testing. Hint 3. Latency-based routing optimizes for speed, not for failover. Answer C. Explanation. Failover routing is designed exactly for this use case. The primary record points to US East 1 with a health check. The secondary record points to EU West 1. If the health check fails, Route 53 automatically serves the secondary record. Health checks can be manually forced to fail for testing without actually disrupting the primary region. Why not A? Weighted routing with 100% 0% is effectively static. It doesn't automatically switch when the primary fails. Why not B? Latency-based routing picks the fastest endpoint for each user. It doesn't automatically exclude a region based on health. It would still route some traffic to an unhealthy US East 1 if latency favors it. Why not D? Geolocation routing routes by user location, not by endpoint health. European users would be stuck on EU West 1 even if US East 1 is healthy, and North American users wouldn't fail over to EU West 1 even if US East 1 goes down. SAACO3 domain. Design high-performing architectures. Task 3.4. Exercise 3. Architecture challenge optional. Nimbus is expanding internationally. They want eatnimbus.com to load quickly for users on the West Coast, the East Coast, and Australia. They also have a regulatory requirement. Orders placed by European users must be processed by servers in the EU. Design a Route 53 routing strategy that addresses both requirements. What routing policy or combination of policies would you use? What infrastructure in each region would you need? There is no single correct answer. The goal is to practice multi-region routing design. Post-credits scene, eatnimbus.com was live. Maya had typed it into her browser, and the Nimbus ordering page had loaded. She'd ordered arepa from her own family's restaurant, just to test the flow. The order had gone through. The kitchen had received it. She sat back. Tom was already reading the Route 53 health check logs. Response time is 47 milliseconds from US East 1. Is that fast? Maya asked.
But
For a user in Seattle, Tom looked at the latency graph. About 80 milliseconds. Maya thought about that. If most of our customers are on the West Coast and our servers are in Virginia, every request travels from Seattle to Virginia and back, Leo said from across the room. Speed of light. You can't beat physics. So we need servers closer to Seattle, or something closer to Seattle that serves content on their behalf. That thought hung in the air. In the next chapter, the warehouses that put Nimbus's content a millisecond away from every user, everywhere.